the wedge will undergo some displacement. Why it will undergo some displacement? The block will be, m1. So it will having some velocity, say v1 dash. This will have velocity v2 dash. What are the forces that are acting? Only let me show the normal contact. N1 on the wedge, N1. Then the velocity of the wedge should be like, why the wedge should move back? Because of N1 sine theta, and there'll be also the weight will be acting. In the normal contact from the ground. Okay, let's have this one. The weight of this also will act. Show all the various forces that are acting. No, net force on the system along x-axis. 0, no? N1 sine theta, N1 sine theta. Net force on the system along x-axis 0. So therefore, the momentum and the center of mass will not shift along x-axis. What about y-axis? As net force is non-zero, center of mass will shift along y-axis. This much is there. And now, what is the state of the wedge? Why it will move back? Because of N1 sine theta. The finally, now, what is the next part of the problem? We have lost such students who really draw diagram and solve the problem. I'm telling you very clearly. We don't have students. First of all, students don't have patience. Sir. Absolutely nil. Question, answer. Question, answer. Don't want to learn. They want to become clerk or accountant. Nobody wants to draw diagram, free body diagram, analyze. The moment you see question, answer should be there. The moment you see question, answer. There is a reason why you are landing in this trouble. Earlier, students used to learn less number of problems. Do you think that? I think till 2005, I know students, they used to spend only with SC1. I need to. These are the two books, finish out. No other book. And exams, like only in a year, their maximum monthly one exam. Grand test, some 5 grand tests. They were very good in knowledge. Now, weekly 3-4 exams. Teacher is teaching hundreds of numericals. Helpless situation. What is the reason there? The students are not doing the problem complete. Just only 10% they're doing. How much is there in book? Okay, find velocity. Okay, velocity. What will happen? Everything. There are so many things are there. If this is rough, anything will happen. If this is rough, anything will happen. How do you analyze? Very openly, I'm asking this question very openly. You may get hurt, but the reality is what I should speak. If this is rough, what will happen? If this is rough, what will happen? So many things are there, no? How come this problem is over when you get answer? If there is some like a groove is there here, then what will happen? Or if this part of the wedge is removed, then what happen? It will fall. Unlimited, no? The students what happen? After reading question, they used to analyze all the cases. Okay, there was a completeness of the knowledge was there. Now what will happen? Solving thousands of questions, still no clarity. The reason for that, just if question is there, you know how to think. On your own, you don't know how to analyze. This is a very dangerous path. Okay, I got this velocity. Now what will happen? Okay, is this maximum velocity? Because he's asking that maximum velocity. Because what is the question asked? First we'll get the answer. Okay, this need not be maximum velocity. Now further, the block will start moving up now here. The block will start moving up. As it starts moving up, what will happen to the velocity of the wedge?
It reduces.
It starts decreasing. It's not decreasing. And where do it will come to rest? It will come to rest at highest point. And what is the state of wedge? Wedge will be at rest. So next sequence, what will happen is like, so many diagrams. What do you expect? The wedge should be at rest. Okay, and the block will also come to rest. For a moment, it will be at rest. Instantaneous IR. IR means instantaneous rest. Then again, what will happen? Again, the wedge and again the block starts moving again like this. The block and the wedge will be oscillating. So, what is the maximum velocity now? This was the maximum velocity. This V2 is what maximum. Are you getting? This V2 is what the maximum velocity. How to calculate this V2? How to calculate that V2? Applying conservation of mechanical energy. M1 GR equal to. Okay, this like this. I'll get the V1 and V2. Two unknowns are there. I need one more equation. Conservation of linear momentum. Initial momentum 0, final momentum. And this V2 is in fact the maximum. Okay. We have to analyze the situation. Anything will happen to center of mass. Center of mass will not shift. I didn't draw a diagram properly, but the center of mass in fact will not shift. Whatever happens to the block, how they move, let it be. Where the center of mass of system, it has to be there only.
Sir, it will move along y-axis, no, sir?
Along y-axis it will move.
Yes, sir.
Now the same problem, I'll give some small twist. Let's see that how you think on this one. I'm really testing my students. Let's see that how well they can analyze the situation.